Welcome back, y'all. We are continuing with our investigation of the Electronics Learning Laboratory Kit. In this video, we're going to do our first circuit build. Specifically, we're going to build this circuit. It's a simple resistor circuit that has one voltage source, one resistor, and uses a breadboard. So this that you see right here on screen, we're going to call that a wiring diagram because it gives a representation of what it would mean if we actually wired this circuit up. When we go to the corresponding circuit schematic, that's going to look as you see on screen here. We're going to use one voltage source, one resistor, and we're going to connect those two things at the dots that you see there. We're going to talk much more in later videos about how to create schematics and then how to label them. One of the things that we'll see is that every voltage source we'll label with a V, and then we'll count the number of voltage sources right next to that. So capital V1 is the first voltage source. Right under that label, we're going to put the value that that voltage source provides. So in this case, it's a 5-volt difference in the two leads. Over here, where you do the same thing, in this case, instead of the letter V, we'll use the letter R because this is a resistor. So this is the first resistor in this schematic, and its value is 1K. Now, strictly speaking, we should say it's 1 kilo ohm with a little capital omega, but electrical engineers have the convention that because resistors are usually measured in ohms, when we put 1K, we automatically know that that's going to be 1 kilo ohm. Again, here is the wiring diagram that helps us as individuals figure out how this works when we're actually going to build the circuit. Do you see that in Fritzing, it actually highlights all of the green points at which those are connected? And that's because once we connect the black lead to A20, all of the pins or all of the points in that row are electrically connected because of the contact strips that are underneath that plastic casing in the breadboard. The same thing's true up here. We'll see that again when we code that up. So that's the wiring diagram. This is the ideal schematic. Let's go ahead and take a look at some of the directions that I try to give in this introductory workbook. So in this case, we're going to need some parts. We're going to need a breadboard, which it says right there. Let me go ahead and zoom this up a little bit. So here's our breadboard. The next thing we're going to need is a one single resistor. So we go ahead and grab our bag of resistors. I think I might have a loose one or two. Yeah, there they are. So we have one resistor. We also need a 5-volt voltage source. So we know that our voltage source in this kit looks like that. And the final thing that we need is a fully charged battery. We'll talk later about how to figure out whether or not your batteries are fully charged in a working classroom environment. I just purchased these things recently and I haven't used them, so I know for sure that thing is fully charged. Okay, so now we're going to build the circuit. This is really clear instructions on how to do that. The first thing that we should always do when we're building a circuit is just disconnect the power from the actual source. In this case, they started disconnected, so I'm good on that. Now we're going to insert our resistor across E10 and E20. So let me go get my precision. I don't think I have it close to me. That's okay. I'll just use my fingers in this case. So E10, I'm going to go down to E10. I'm going to insert that. I remember there's a great question by a colleague of mine, I think from somewhere up north. Mark asked me, how do you know when to stop? Well, the answer to that question is I go all the way into the hole, the little contact point there, until the end of my resistor, the lead of my resistor, hits the bottom of that contact strip. Remember from a previous video, there's a metal strip in there that kind of has a U shape. It actually looks like this, to be honest with you. And so what I'm going to do is I'm going to take the whatever component I'm putting in and just go all the way down until the lead touches the bottom of that contact strip. And you'll kind of feel as you push the lead into that little contact or the point there, at some point, like I can't push it down anymore without bending the metal. So the same thing's true down here. Great question, Mark, by the way. It's just a gorgeous question. So I push that thing down in. So now I have my resistor across E10 and E20. Next thing I'm going to do is I'm going to take the red lead of V1. So this is V1. Here I'm on 0.3, and I'm going to put it in A10. So now I'm at A10. And then I'm going to take my black lead of V1 and put it down into this is A20. Okay. So now I have that circuit set up. And indeed, if I were to go ahead and check with the wiring diagram that I had earlier, that's exactly what's happening here. I haven't attached the 9-volt battery, obviously, but literally the expectation that I have for the circuit build is identical to the actual circuit that I've constructed. The ideal mathematical model for the circuit, which is the schematic that we see here, represents this idea. Now, I will say, notice that in this ideal model, the lead above the voltage source, the positive lead of the voltage source, connects to the top lead of the resistor, and it's one piece of metal. This is where our investigation of the inner workings of the breadboard comes into place. This is literally just a piece of insulated wire. When I put this insulated wire into that metal contact strip, it makes an electrical connection. So those two pieces of metal are now in contact. And from the standpoint of electrons, it becomes one piece of metal because electrons can flow freely from the red wire to the contact strip. That contact strip runs all the way down and touches this piece of wire or metal on the resistor, and then all the way up here. So from the standpoint of the electrical behavior of this, every bit of metal inside that red wire, all the way through the contact strip, all this piece of metal, it's one piece of conductor. We'll call that a node in later videos, but that's why you see that they're all kind of identical. I am going to, in the early stages, put a dot here. Later, as we get more sophisticated, I will not put dots at connection points, and we'll talk more about a heuristic problem-solving technique that we can use to identify where the nodes are. Okay, the next thing that we do, we recognize that this black wire touches the contact strip, touches the other side of this resistor, and so that's all one piece of metal. It's one conductor, which is why it's represented that way in the mathematical model that we have here. And then this component right here is the thing that provides the 5-volt difference. Here, when I connect this battery, this circuit is now working. I'm going to do this just as a demonstration. I can touch this and there's no safety problem. Now, please, when you're doing these at home, for my students anyway, students that have access to this or other folks that eventually get access to these kits, I would encourage you never to touch live electronic components, but I just wanted to demonstrate, like, we spent a lot of time thinking about how to make this safe and effective for students. We have now built our first circuit. And what we're going to do next is actually test it. So the thing that once we have this circuit, one of the really kind of fun attributes of each electrical component is we can use a digital multimeter to test the voltage and current measurements associated with each electronic component or each circuit element. So in this case, we have two circuit elements because we have one resistor and one voltage source. We're going to collect physical data using measurements. Now, most people do not go around in their daily life collecting what I would call electronic measurements and recognize it as such. So the way that you can, if you've never really taken electronic measurements, think about this as a ruler. So what we're basically going to do is try to measure certain quantities, and we can think about it in a ruler in the sense that we're going to use some technique to figure out what the difference in height, I suppose, or potential is between this side and that side. In the next video, we'll see how to use a multimeter to measure voltage, and we'll also talk about what the interpretation of voltage that I prefer to think about, and I would coach for young students that haven't taken physics yet. These are kind of how I would think about those. I'll see you in the next video.